Ladies and gentlemen, it's my great pleasure and honor to welcome here in Prague at the Czech Technical University Professor Wolfgang Wahlster, who is Chief Executive Advisor of DFKI, that's German Research Institute for Artificial Intelligence. He was a founder of this center, and as a matter of fact, he managed the center for more than 20 years. Yep. Currently, he continues in his research activities. He is well known as a, let's say, godfather of Industrie 4.0 concept. Together with Professor Kagerman and his Professor Lucas, they announced this concept in 2011. Officially, it started to be a concept of German government since 2013. And the ideas of this concept influence the area of manufacturing, especially in Europe, in the last decade. And as a matter of fact, the ideas of linking together, let's say, computer science, control engineering, artificial intelligence, but also Internet of Things and all the Internet efforts are the leading ideas beyond the concept of Industry 4.0, which is still in the progress, in development. And today you will listen to the presentation, which will bring quite a new and pioneering ideas concerning the future trends in Industry 4.0. I would like also to mention that Professor Wahlster is the honorary doctor of the Czech Technical University and several other universities. And this presentation is organized within the frame of RICAIP, that's Research and Innovation Center on Advanced Industrial Production, established jointly between Czech Technical University, DFKI, SEMA, and Technical University in Brno. But it's strongly supported by European project INPACE, which started this year and which brings together researchers from EU, India, and Asia Pacific area. And it's my great pleasure and honor to welcome also listeners from India. There is a bunch of them today. So welcome. And now I'm giving the floor to Professor Wahlster. Before I'll do this, I would like to inform everybody that there is opportunity to put questions to Professor Wahlster via SLI.DO. You can use SLI.DO. You can use also the screen here and on our website. So please don't hesitate to put questions to Professor Wahlster, who will answer them at the end of the presentation. Wolfgang, it's your turn. Thank you very much.
Yeah. Thank you. Thank you very much, Vladimir. And first, I should congratulate all the Czech people here for the wonderful game and especially the result. So you are not only the world champion in industrial AI and Industry 4.0 and with CIIRC and also the RICAIP Center, but also in ice hockey, second thing, and very good. I really enjoyed the game and was very excited about the result. So now let's come to our topic, the Hybrid LxM. X means that we can substitute the X with a lot of different letters, for instance L for large language models, large action models, large process models, and so on. And hybrid I will explain later. I think this is a booster for Industry 4.0, and therefore I discuss this in this context. And of course, as Vladimir already mentioned, this talk is very much supported and inspired by the work of RICAIP, Center of Excellence here, which really is a big success. Of course, the mother of everything is CIIRC and the university. We should not forget the university part, and DFKI. Here's an outline of my talk. First, I will discuss a little bit about the future of Industry 4.0, the next decade, especially research roadmaps. I was asked by the German government to prepare the AI roadmap for industrial AI and submitted it at the end of last year. But we have also another roadmap which I was involved in, but the head of this was Professor Liggesmeier from Fraunhofer for the the engineering roadmap for Industry 4.0. Then I will go into from talking to actions. That means neurosymbolic LxM technologies is a more technical part of the talk, and give also 2 examples of where these technologies can be used. And finally, I will also go into the very important topic, active digital twins in the industrial metaverse. We saw this at the last Hanover Fair as one of the hot topics, which is now also used in industry. And then I will conclude. But first, let me discuss very briefly the confusion which came up when people on the European level, especially in Brussels, and with some influence by professors who called themselves experts in industrial AI, but I couldn't find the papers. They have introduced, tried to introduce this topic, and we said that we should be very careful because the concept, as they presented it, does not contain any new content, and it falsely suggests that the fourth industrial revolution is already complete and that our attention can be turned to new topics. This is also political dangers because, as you all know, politicians always tend to, that they want to talk about something new. And the typical software shorthand 4.0 was used on the one hand to count the industrial revolutions that we had. And if you look in the history, the first, second, and third revolution took more than 30 years to really be broadly introduced. And we cannot speed up. We are fast, but 10 years would not be enough. And if you look at the reality, at least in Germany, maybe we are slower than Czech Republic, but in Germany we have less than 30% of the factories already have introduced the standards. So we have not reached a TL level in many of the technologies, but also the companies are a little bit slow to adapt to this, but it's quite normal. If you go to some countries today, let's say in South Africa, you will see the first revolution has not finished yet. When you look at the how they do agricultural, on farming and so on, this is not a second or third revolution, and so there is always an overlap, in geographical distribution, and therefore we should be careful to say this is finished. Also, what they propose from a content point of view, namely sustainability, that we should look at, for instance, the low energy consumption in the factory. This is, and if you go around here in the test beds, you will see this is active topics in Industry 4.0, actually from the beginning. I even remember our Chancellor Merkel saying to me, Wolfgang, please have resource-sensitive Industry 4.0 factories from the beginning. And actually, the first factory which was opened in Stuttgart already had this as a title, that they say this is low energy, it's a green factory, we want to have urban manufacturing. So it's complete nonsense that this was not done. And the second one, I was even the chairman of the task force for human-computer interaction in Industry 4.0. And again, this was a topic from the beginning. So a new term is not needed to describe at least the concepts which they propose. So we have societal benefits and we have the goals from the outset. So we should avoid this term. Maybe there are other definitions I just heard, but that's another thing. Just to show that this is not a post hoc argumentation. This was the original slide which I showed actually at the first meeting of Industry 4.0 in a very small circle together with our Chancellor. And you see all this, what I have said, resource efficient, clean and green production, increasing product variability, shorter product life cycles, the lack of skilled workforce and so on. These are problems which are still there. The socio-economic drivers of Industry 4.0, all these problems on this slide are not solved, and we are now more than 10 years later. So there is enough work to do in the next 10 years. And therefore we need roadmaps. What exactly should we do in the research in industrial AI? And this was, as I said last year, I was commissioned to do this, and I said the overarching topic should be long-term autonomy in next-generation industrial AI systems, because what we see today with AI is always very short-term autonomy. Our robots can work, let's say, on a specific task for a couple of minutes in a very concentrated way, but they are not autonomous over months. And when you tell a AI system, a factory management system, yeah, please optimize this factory so that in 3 years the yield of our products is 10% better, they could not do this, of course. Yeah? And what we want are systems which have longer-term goals and can follow these goals over longer term. I will not go through all topics of this roadmaps, but just to pick some, and you will see that many of them are also addressed already as a starting point here, now in 2024, when we go around the lab here, already now. We have the chance with cognitive assistance systems that the programming of robots is partially substituted by automatic programming, especially with the LLM paradigm. With machine learning, we already managed to program simple robot action fully automatically from learning how to code in a specific robot programming languages. The next thing is, of course, home workbenches. And again, in our network here, I think CIIRC also works together, for instance, with Vicomtech in Spain, in San Sebastian and Bilbao, and they developed, for instance, such a workbench where you can really do distributed working from a remote place. And we have this done also here in our test beds, both in Saarbrücken, Kaiserslautern, and here to have not only remote office work, home office, yeah, but we don't need this home office in the factory. It doesn't make sense. We need home workbench, and this is much more complicated, yeah, because you need a much higher resolution of the work pieces and also other ways to interact. You cannot do this by just typing on a keyboard, and so on. So the upper part are more complex things which we are not in reach today. For instance, hybrid teams, robotic teams for complex tasks where you have various robots working together with various workers, skilled workers and experts in a real team. We tried this already on a foundational basis in our project we called it High Society, and it worked, but it was very brittle. Of course, this was a small demonstrator, but to make social robotic systems a reality, I think a lot of research has to be done in the next 10 years. Let me jump right now. I think trustworthy systems, you all know, is one of the very important topics. To have also factory safety and to have to use also AI for fighting attacks to your factory and so on. So this is, of course, a hot topic. But let me go to the industrial metaverse, which I will show later in more detail. I think that there is a lot of potential of the dual reality approach and distributed production. Again, we work on this already, but I would say that there are no real products available today to really solve this problem. In the long run, I think we want to have an incremental quality management by plan recognition and active sensors. Finally, as I said, we want to have self-organizing production in the sense of long-term autonomy. We are starting this now again with reliable large language models for creating and interacting things with active digital twins. But in the long run, I mean, the vision would be that in 2033 we would be able for generative AI for really self-manufacturing systems, where the system is also able to reconfigure a factory, a smart factory, in a way that it can actually produce a completely new innovative product. At DFKI, we have also tried to catch up. The German government has approved a so-called action plan for AI in November last year, and this enabled us also to increase our network of institutes. So you see here the German map, and except Bavaria, which is the free state of Bavaria in Germany, in more or less all states we have now DFKI, either labs or real big sites. So it's a big extension of capacities. And in Germany in general, I'm also on the executive committee for steering the AI funding program, so-called platform intelligent learning systems. This is now realized, and we count. You can go to this web address here, Map on AI, and then you see over 1,000 applications, real applications, which are in daily use by SMEs and so on, funded by the government. About 300 research organizations, not all on the top level, of course, and a lot of AI study programs. We just discussed this with Vladimir. I think the education and the lack of talent is extremely important. So 700 new study programs, also some of them not only on the excellence level, because it's not enough to have only excellent people. You need also normal or people who cannot make it in the excellence level, and still they are very useful for many jobs we have in Germany. And finally, we have a discussion of the transfer on the federal and the state level. What is also very important for us is the lack, or let's say the advantage of the US companies and China in very high potential or computing facilities, and but there is a very good chance now, because this idea of the chiplets, which is now also already a reality, that you can produce very fast and much cheaper systems on a chip by having AI tasks distributed to smaller subunits of the hardware. So we all know this from FPGAs, but now the new trend is to have also super chips, as sometimes they are called, for AI acceleration. Of course, the classical CPUs, but also GPUs, all on one chip. And the interesting thing is that these chiplets, as subunits, you can configure to have a very specific AI task accelerated by one chip. Yeah, this was much too expensive and took a lot of design time. But now, when you do this in this chiplet way, I think a new industry can emerge, and especially here in the Czech Republic and Germany, where we have some specialists for semiconductor design, but not enough, let's say, also economic capabilities to build always a new chip factory for one single chip. I think this modular approach can lead us to a lot more AI support by hardware than it was done a couple of years ago. This chiplet thing is very new. I was in Taiwan. I saw some demonstrations already of chiplets. I think it's really looks like a very good future, because then then we have a large catalog of chiplets in a couple of years by third-party specialized IC vendors, and then we can, in a Lego-like assembly process, using, of course, standardized interconnections between these chiplets on the one chip, which is already established. It's a Universal Chiplet Interconnect Express, so that our colleagues from electrical engineering did a very good job to normalize this and standardize this very early. And the expected reduction of design costs is about 70%, and also turnaround time. So I think this will give a new boost also to the whole idea of AI in Industry 4.0. And finally, this roadmap section, I will close with the engineering roadmap. This was designed by, as I said, Peter Liggesmeier, Professor Kagermann, myself, and Professor Andal, together with our so-called Council for Industry 4.0 for research. And here you see it's very similar to the AI roadmap, but it has some other aspects because it's more on the engineering and higher TRL level. It's not so much about research, but again, the autonomy is one of the long-term goals for 34, and before we go on with optimizing existing factories by doing more machine learning, human machine and organization, new technologies for this, and of course the information acquisition will be also accelerated right now. There are already some projects in this direction. You have maybe heard from Catena-X as a use case, which was a very successful project in the logistics for automotive industry. This is already deployed, and the data exchange and the learning worked very smoothly. And right now, there's a preparation phase for what's called Manufacturing X. Yeah, again, its approach along this roadmap. And then in industrial AI, you all have heard about ATRA, Eclair, AI Crit, and so on. There are a lot of projects on the European level. And then for the software platforms, we have the Gaia X projects, which are, of course, in line with Catena X and MX, Manufacturing X, because they are kind of predecessors. One of the lighthouse projects, which is sponsored by the German Ministry for Economic Affairs and Climate Change, is Manufacturing X, as I said. There is Siemens, SAP, DMG, Mori is involved from Japan, and DFKI's Smart Factory. And you see all these topics on these slides, like modular production. You can go here already through the labs of CIIRC and especially the RICAIP test beds. Condition monitoring, clear. You have a lot of demonstrations here. You are carbon footprint. I remember that already 2 or 3 years ago you had a demonstration about this circular economy. This is now starting here. Traceability with digital twins, very important. You see, all these topics were already, fundamentally researched, but now it's time to transfer them into real industrial products and to make also the return of investment very clear to also smaller enterprises. In DFKI, we help with this. We have every year we produce in our smart factory a new demonstrator. The last one stressed the topic of edge devices, edge AI, active sensing, and using the asset administration shells everywhere. All the objects and all the processes should have a digital twin here, and we demonstrated the system again at the Hannover Fair just 1 month ago. It was a big success, because now more and more small and medium enterprises, startups are ready to really adapt this technology. And in Manufacturing X, one of the key ideas behind RICAIP, namely distributed manufacturing and also distributed platforms, is also used now by industry. And I was surprised because at the beginning many people were skeptical about things like federated learning, also federated operating environments and so on. But now even SAP and Siemens are very much behind this, because they saw that if you have the traditional platforms, which the European Union and also Gaia X at the beginning supported very much, for different reasons. In many cases, these are legal reasons, security reasons, and so on. And also the small and medium enterprises wouldn't accept it. They now go to a more distributed model, which exactly fits what we have doing here with RICAIP already all the time. Now let me come to the more technical part of the talk. As I said, the latest AI trend is to go from LLMs, and LLM is, of course, a success story, we should say. Also, there are still a lot of, let's say, obstacles, and there are also some foundational problems with this. But overall, for many subtasks in AI, in vision, in speech recognition, it's a success story. No way around this. The problem is the trustworthiness and so-called hallucination, of course, is the downside of this, and therefore it's not the end of the story, but it's a good starting point. So the large language models are okay. What is new now is that the so-called LAM, large action models, where you have not only, as in generative AI, an output which is either text, speech, vision, even videos you can produce, as we all know, with LLMs, but they don't act. They just talk, present, but nothing happens in the end. And so a lot of people complain now in industry, at least in Germany, that they say, we spend a lot of money of asking the system, then we get some results, but what should we do with all this? We have already enough text and videos we see every day. What we need is a system that you really can give certain tasks to the system, and it takes care. It completes the task, or it even does the task fully automatically, really carrying out. So the execution and the deployment is missing in normal LLM technology. And here the idea of multi-agent systems, of course, comes up. And here we have in the room with Vladimir, one of the pioneers in Europe for multi-agent systems. And it has a long history, I think, in CEIRC. The technology is very mature, I would say. It's not rocket science in some points, but it's very useful, and you can exploit it. And so LAMs, as a next step for really autonomous personal assistants, they make decisions, they take actions on behalf of the users. Of course, here trustworthiness is even more important, because if you give your credit card to your LAM, it's dangerous in comparison to LLM. It can interpret your needs and complete the task, and it predicts what to do next, in contrast to what to say next. If you look at the probabilities which are generated by LLMs, it's, the next word is predicted, or the next part of the text, or the next frame in a video, but nothing really happens. And this is now the new approach. I think the cognitive load, which we have all now, if you look on your smartphones with all these apps, in most tasks which you have on the day, you have to call many different apps. You have to remember all the different graphical user interface and how you interact. So the German Telecom had the interesting idea to have the app-free smartphone. That doesn't mean that you have no app functionality, but you have only one app, let's say the super app, which does, combine all these apps in one, so that you learn only the interaction with one. And I think this is important, and it will actually challenge the App Store paradigm. If you now look at the Google or the Apple App Store, it's absolutely, crazy how many apps you have for the same task. I can have in Germany, I think 20 different weather apps alone. Yeah, and before you travel, you look at the weather app, you look at the train app, you look at the hotel app, and whatever. This is really confusing. So what we need is a combination of LLMs with multi-agent systems, and this includes also things which go outside the normal stochastical learning. We need automated planning, of course also reasoning, really logical reasoning, user modeling, formal verification, and validation in this case. Let me just give you two examples. I already mentioned the app-free AI smartphone, which is only a demonstrator. It was shown in Barcelona at the last Mobile World Congress. But more interesting are commercial software platforms, which are now emerging. One is from DFKI, and I'm involved also a little bit in the birth of this company. This is called Expect, and they do process mining, just normal, also machine learning, of course. But what is new is that it's an orchestrated combination of generative AI, knowledge graph, and formal reasoning. And the domain is that the system should do automatically a audit of, which is very important today for companies, audit of the compliance with regulations like ESG now, where you are only compliant if you can prove that you do sustainability actions in your company, for instance. Yeah. And also the normal audit from the financial point of view. And these people who were founders are, on the one hand side, mathematicians, trained AI people, but also people from consulting, KPMG, for instance. KPMG is one of the largest auditing companies, and they have all the knowledge how you do an audit, yeah, per hand. And it turns out that this is a good domain, because on the one hand, you can use text, which is produced by such auditing companies, and on the other hand, for training, and on the other hand, it's a thing which is urgently needed to make this much faster, and then in the end also cheaper. So this is one company, and in the US there are also two companies which go in this direction of LLMs. So to sum up a little bit about this part, we can say we still need, of course, training data. We have the machine learning, but for LLMs, you need more learning by demonstration. You need, of course, reinforcement learning. And what is very important for LLM is that it's also always up to date, and this means we need continual learning. So learning also on the fly, the LLM has to be updated more or less every day. And you see here on this graphics that I feel that there is an overlap, because when I said LxM, this means not only A for action, but there's also the notion of process model. Process model, if you are in business informatics, is something which is discussed already for more than 20 years. There are various models for this, like ARIS, BPMN, but many others are emerging. And so SAP, of course, in Germany is very strongly dedicated to work on large process models. And they have a lot from their customers' experience. And I think they have, of course, an overlap with large action models, but they are different in the sense that these are standardized processes, whereas large action models can be also is a more granular level and can be much more individual. And then we have the multi-agent systems, where I said, task completion, collaboration with robots and humans. And also we do this via APIs, graphical user interfaces, but of course we can also use chatbots like multimodal discourse in the mass system. And our idea is that in the next wave of these LXM models, we will have all three of them, LLM, LPM, LLM, coupled with a multi-agent system. And this multi-agent system can like a subroutine call from time to time other AI technologies. Therefore, we call it neurosymbolic. For instance, the knowledge graph. Actually, when you go to industrial practice, you will learn that most of the companies which offer some LLM application also in the background use a knowledge graph. Why? Because with a knowledge graph, they can sort out a lot of garbage, which is unfortunately also created by the purely statistical models. So I know for sure for some applications with Google, they do this, they have a very good knowledge graph, and they have to sort out. And I know also from some examples from them, then more than 70% of the things which were, learned by the system had to be discarded because they are not compatible to physical laws. The physical law says this, and normally you should say something from physics. There is an equation. You should, believe in it or not. But there were a lot of people for hundreds of years working with this. You cannot challenge Maxwell's equation and so on. But just a statistical system, LLM, which claims something else. So therefore, you better check when you have the information. The LLM is very good because for many parts of our knowledge we don't have physical laws, of course. So that's one thing. Constraint solving, extremely important. Again, when you look to the newspaper, you see only LLM. But if you look to the reality, even Google has a lot of people only working on constraint solving. And they wouldn't do this if the LLM already solves everything. The same, as I said, physics-based simulation, expect here in CEIRC, this is extremely important, and we can see it here in the labs. And finally, we should not forget that we have very good groups, especially here in Europe, in deductive and also abductive inference. And to call them as a subroutine, I think is the way to go. And training still is essential. We can train with text, speech, images, we all know, in LLMs. But for LPM, we need process mining results. And there are a lot of companies, at least I know in Germany already, for companies offering products in this, and also startups like Celonis in Munich, a very successful now company doing process mining, and the results are not semantically interpreted. Of course, here again, by AI methods, we should try to make them semantically accessible. And then LAM training, of course, we have a lot of workflows, we have human action logs, we have checklists, we have instruction manuals, and we found recently that when you crawl the internet, you find thousands of tutorials of how-to tutorials. How do I repair my bicycle and so on? And of course these are action sequences where you can learn and train LAMs. And as I said, to give a more detailed example, when you have this idea of how can we do some audit for a company, then you start with unstructured knowledge. But then you have a lot from the process mining, you have already process models, and then you can form large action models and really go into a dialogue. Here you see, for instance, from SAP, a small subgraph of a large graph, which says, how can this process be done? Here a guy wants to have some the timesheet, and the system reminds on the compliance how to do this in your company, yeah, and it checks whether everything is correct or helps the user and says, now you have to send this to the HR department and so on. Can I do this for you? So we can have different, I mean, either it does this autonomously, and when you learn to work with the system, of course, you are a little bit skeptical, so the system should wait for your approval, but nevertheless, then you say, yes, please, and the system would do this. So really, this would be already also a alarm for the compliance. And it's a little bit like a Swiss Army knife for industrial process management, because it does not only the audit, it can also be a process verification, it checks the compliance of your company, and because this is a very expensive exercise normally and time consuming, I think automation is very much needed, and all these standards which we have now also with the new AI Act, I think will lead to more auditing. Many people complain already, and we have to beat this beast, I think, with our own technology and try to make things as efficient as possible. Now, the AI Quama project, which we do together here with RICAIP and also, of course, CIIRC. Here also Skoda is involved. Our main industrial partner is Volkswagen in Dresden and Wolfsburg. This is a very good cooperation between the testbeds in Prague and Saarbrücken, and we have very exciting results for the industry. Volkswagen increased their engagement, gave another lump of money and also people which are working with us on this, especially to incrementally recognize wrong actions and to find errors. We want to have, in the end, it should be a zero error production, so that we don't have to do a lot of rework or any rework at the end of the process when we find there is something wrong. And now we do this by combining large language models and AI technology with some more traditional virtual measurement data analysis, which is very much based on simulation, on solving a lot of differential equations. So it's a physics-based model. And what it does is that, let's say a car is produced, and during the car production, there are sensors which measure the gap. Yeah, you know, some people say it's a German obsession, especially in Volkswagen, to have the gap size minimized, but this is nonsense, because it's not only the tightness, but it's also the track coefficient. If you have gaps like at the Tesla, sometimes more than 1 centimeter, the record is 1.7 centimeters at a car, yeah? Then your CV, the CW value, you can forget about it, because the car is slowing down, and you need much more energy. The waterproofness is also very important. With these gaps, it doesn't work. So I think important is the visual quality measures also for the customers when they look at the car. So what is done now, before, when the doors are adjusted and measured, this is done in the unpainted condition first. Then you do paint the car. Of course, the lacquer adds weight or stresses. This is done by our colleagues in Volkswagen. There are 3 of them. I quoted them here. And then the doors are dismantled again to make it easier to fit in the interior. And then they are fitted with loudspeakers, windows, and then they are remounted again and refitted. And how can we do this in an optimal way? And this is with the physical model, because the system really computes what you have to do when you, in your private practice, if you have a IKEA kitchen, I remember, you also have this problem, because you cannot only turn one screw, but you have two here, because they are all dependent on each other to make the whole thing really fitting. And exactly in the car is much more complex, because you have the car, you have also windows which add weight, and then, you know, again you have to refit. And what the system does, it actually computes with the differential equations how much torque you have to do here to do ideal fitting. And the workers get this over the classes. They you know, by augmented reality, they see where, yeah, and how much they have to do this in very high speed. It's a complex model, but again, yeah, this is one step in the LAM where we call this physics-based reasoning as a submodel. If you would do this with a LLM, I think it would not work. Yeah, and also this is much more precise. Yeah, because it's based on physical knowledge. So we can bring both things together to have this AI-based quality management. So, as I said, in the first step, we use this tool, which was developed by this group at Volkswagen in Wolfsburg. We simulate it, and the corrective measure in the LAM is then output, and then we can generate nice language for the worker, or we can visualize this in the goggles that he or she sees which steps have to be taken to for correct execution during the implementation phase. What we also have developed, and I think you have similar things here, is that the system does on-the-fly anomaly detection and also mitigates problems in the assembly task. Here, this is an example we have now in our test bed in Saarbrücken, where somebody has to assemble electronic parts, and again there are a lot of constraints, which not only which screws you are using, but which torque you should use, and actually in which order you have to do this. And if this is, for instance, you do it in the wrong order, the system also will tell you that you have to directly fix this error. This is in German, you see that it was put in the wrong direction, for instance. You have to turn it, and again the system controls this. So I think this is the way to go, because as we said, we have not enough skilled workforce. We have to people who jump into this position, you know, without a lot of training, and then they need assistance to catch the errors very early, because if you have assembled everything, it's much more expensive, of course, to correct than when you do it directly. Yeah, in finishing up, I wanted to go also as a last topic to the digital twins and the so-called industrial metaverse. And here you see that autonomous robots are trained based on synthetic data. It's now a big move that we do this. In the first, I think, field was autonomous driving, where also DFKI was involved a lot in generating data for autonomous driving, because, for instance, in crash situations, there is not enough material, of course, on the internet to do this, so you have to synthesize artificial crash data to train the system. But here in the manufacturing, it's also very important to do this, because when we visit a factory like in Wolfsburg, we see so many different types of assembly, different types of errors which happen, that it's really amazing that you don't have enough data points for normal machine learning algorithms. And therefore, training this on synthesized data is, I think, the way to go. And that's one thing. The second thing is that when you have, again, physical models, you also can run the physical model in the virtual environment to have good results. This is an example based on Siemens work, the so-called accelerator, which they already offer as a product together with NVIDIA Omniverse, which is a really excellent graphical system for visualizing this. And they at the Hanover Fair already they had a demonstration, very impressive, of a virtual battery factory of a Norwegian company which really wants to build this factory. But before they build the factory, they already can really, they have even a big demonstration board where they can show when the factory is running, what does this mean? How much training data do we collect? How fast does the machines generate something? Here you see actually physical processes, then also visualized. It's really a fantastic environment that before the customer decides to order, by Bosch Rexroth or by Siemens or Sartorius to build a factory for a special discipline from biopharmaceutical production up to, automotive. They want to see what will be the effect for our production, and if you can really simulate this in the industrial metaverse and ask questions and check alternatives, I think it's extremely important. And I think this is the way of the future. And again, we need, of course, the different AI technologies. And again, the generative AI parts are important, but not only. Let me also mention at the end that my personal observation is, and last year I published a paper about it, that I think that normally if you have only generative AI, it's not good enough. You need also analytical AI, because when you generate something, I think already 15 years ago in the AI journal I published a paper, I think the title was No Presentation Without Representation. If you don't know what you have shown to somebody, you are in big trouble if the guy asks, what is this and this. And this is a little bit what happens with generative AI. They generate a very nice picture, and this is good. I don't criticize. I think it's very important. But on the other hand, you should be able to have a system which looks at what you have generated and better check whether this complies with your intention, what you wanted to show. Sometimes, there's a lot of criticism that the system generates something random. It looks good, but it fails the purpose. And I think humans are very good that they go to what I call a feedback, anticipation feedback. They can have analytical capabilities which can check whether what you are saying will, again, probably generate the effect which you intended, and therefore analytics are also very important. And finally, you can use such technology also for the training. Vladimir and I discussed already yesterday, there is such a demand that also I think institutions like CIIRC, like DFKI are also obliged, together of course with the university, to increase the output on talented people for the next generation of AI applications. And so the lack of human resource is even worse, I think, than the lack of hardware. Some of us are also complaining about this. Let me conclude by saying that Industry 4.0 is an export hit right now for both Czech Republic and Germany. I think our two countries are definitely leading. I remember that Vladimir was the first in Europe also to publish a book in the Czech language, in his own language here for Industrie 4.0. So you were here from the start. As you said, when we started in 2013, you already started also here very quickly, and now I think we are absolutely on the same level. When the RICAIP was started, this was under the teaming program of the European level, and at that time they said, okay, Germany has 1 or 2 years of advantage. They started a little bit earlier, so help our friends in Czech Republic. But now this is no longer needed. Actually, I would say in many disciplines you even have generated more substantial knowledge than in Germany. So it's at least the same level, same playing level. And this means you can now also export these ideas. And I'm very happy when to hear that now next year, Masik Institute will be opened in India. Congratulations. I think this is a fantastic idea because it's a transitive closure, so to speak, when you go on like this with teaming, because now Czech Republic helps India, and this has always not only a scientific but also an economic effect. This is that there is, for the talents, but also to have new industrial contacts, and maybe some plants from India will be also established here in the Czech Republic. In the next decade, I think that LLMs will be complemented by large process models and large action models, so that generative neurosymbolic models not only predict what to say or visualize, but also what to do next, like with the super app. I think it's a very simple example. I want to have a trip to Prague, and I don't just get the train ticket, but also the hotel is booked, a taxi is booked, and so on. The weather report, everything is compiled already. Active digital twins, holonic multi-agent systems, and the industrial metaverse should be used on every level of Industry 4.0, and they are the enablers, in my vision, of circular economy and new working models based on industrial AI. So thank you very much for your attention, and best greetings to India.
For your exciting lecture, which shows the future trends for next decade of Industry 4.0. I would like to thank you. And there are a couple of questions which appear on the slide. So I'll start with 2 questions from anonymous person who asked before you have started, why you asked the German government to stop the use of the term Industry 5.0, doing so 9 years after its launch on December 2015. And the additional question, have you analyzed the differences between Industry 5.0 original version and the version adopted by European Commission in 2021, because Commission changed a little bit the opinion about Industry 5.0. So, please.
We looked very carefully at this. Today I learned there is an alternative, but the original proposal and also the revised one stresses 2 things which, as I said, were there in our conception from the beginning. Otherwise, we wouldn't have gotten the funding and also the agreement by our government. The first was the human in the center, human-centric. And as I said, I was the chairman of this group, and I can show you documents, hundreds of pages about this, and also the concrete work. So this is complete nonsense. And the second one was the sustainability issue. And again, as I showed you, we even have the quote of our chancellor when she officially opened this, that they said this is the first program which from the beginning has urban manufacturing, a low power consumption, resource sensitivity, and so on as a program. So therefore, we don't like this, and I think it's not good that the maybe some people are a little bit have envy that they say, in Prague and in Germany, this is a big success, but it's open. So many countries like Spain, France, when you go around Europe, most of, I would say 80% of the researchers use the term Industry 4.0, and it's appropriate because it's the fourth industrial revolution. If somebody claims this is fifth, then first she or he should explain why is this a new revolution? Where is the revolution? Of course, you can say the goals of Industry 4.0, and I showed this today with the roadmaps, are always a little bit moving target if you go down in nitty-gritty details. Of course, today the let's say discussion about resource sensitivity is different 10 years ago. 10 years ago, we were running around with a CO2 footprint. Yeah? CO2 footprint still is an issue, but today it's more alternative energies. Like, it was unclear that we want to go completely in Germany out of the so-called fossil energies. And of course, details may change. But I think in a revolution, if you go back in the second revolution or third, it was the same. Of course, on a granular level is shifting, and this would be very bad if the revolution has a program which is constant, but the long-term goals are not different from what we have predicted.
Thank you very much. There is another question. Some people are probably not satisfied with Industry 4.0, and the question is, do you think we are already having Industry 4.1 or 4.5 when we can expect this?
4.1?
4.1, because we are making progress.
Oh, I see. Yeah, but as I said, that is a good question, and I think this question can be asked. But then everybody who does this does not understand that when I invented the term itself was coined by me, and I proposed it to Professor Kagermann and so on, and they were excited because I said, this is ambiguous from the beginning. We want to say because it's the fourth revolution. Then .0 was only a pointer to this idea that this is very much software demonstrated, that the software industry will play a big role compared to other revolutions which were more physically based revolutions, so the software aspect. And therefore, the notion of this point and that you have the versions was just introduced to highlight this. What we don't want to say, we have a revolution 4.1, this doesn't make sense. This is the fourth revolution, we will only have a fifth. Of course, one can say, okay, quote, that we make progress in 4.0, so why not use this? But I think it is not compatible with the second reading. So in linguistics, we say there may be two readings of something. Industry 4.0 may mean this is the software version 4.0, but it's also saying it's the fourth industrial revolution, and we cannot introduce a 4.1 revolution. That's the reason.
Thank you very much. And the last question, can you comment on the impact that the new humanoid robots will have in the industry within the time frame of the shown roadmaps, the role of humanoid robots?
Yeah, I think the humanoid robots, again, has a little bit two readings. I think if you want to have a humanoid robot in a factory, it's a different thing than a humanoid robot for elderly people, or a humanoid robot in Walt Disney movies and so on, because there are certain parts of the humanoid robots which are very important for the industrial skill level, but they are not important. There are others, for instance, the empathic part. Prosody. I think the prosody, the emotional level of an industrial robot, we don't need. Even humanoid. Humanoid in this case means only that you can use this robot as a substitute of a human worker at the same workplace. Because today we still have most of the robotics environments are fitted to the robot. Yeah? And once you do this, no human can use it anymore, because it's the environment was designed to do the job by robot. And therefore, I think humanoid robots and factories are very important. Why? Because they can jump in whenever a human cannot deal with it. It's too complex from a cognitive point of view or the skill level, or it's just simply that the robot is out of order, has to be repaired and so on. And I know many situations. I will give you a concrete example where we are working on logistics of mobile robots in a factory. These are actually what we call in German forklifts. Forklifts. These forklifts, there are companies like Jungheinrich, many will know, it's one of the leading companies, and there is a driver normally. Now we have a version of this forklift, which is run by a robot, but you still, when there is a problem with the robot, you still can jump in as a normal driver and use the forklift. This is, in my mind, more anthropomorphic humanoid robotics, because you always think, could a human worker take over the control and do the job? And this is not, and you need this in many situations in industry also. But they look very different. When you look to Hollywood movies or some of the newspapers, and they say this is a humanoid robot for industry, I would say this is not feasible. You don't also need it. Why should you have industrial robot which is laughing and so on? But you need it, of course, in elderly care, for instance.
Thank you very much. It was the last question, and I would like to thank you once more, Wolfgang, for your presentation and excellent answers to the questions. And thank you very much for coming and giving the...
Thank you for your invitation. Thank you.
Thank you very much.
Thank you.
For you to meet for a while Professor Wolfgang Wahlster.